Okay, everyone, our next plenary talk is a little bit special. It's a plenary panel that will be led by Ken Goldberg. I will do a very brief intro so we can leave more time for the panelists. I will first read out this distinguished panel of colleagues. Their names: Ken Goldberg, Maria Pia Fanti, Pieter Liu, Peter Abbeel, Kaneko Harada, Michael Wang, Kevin Lynch, Chinwe Ekenna, Animesh Garg, Frank Park, Seth Hutchinson. So there are multiple chief editors and senior editors and president of our society, et cetera, and our emerging leaders. So this panel, the topic is to explore the synergies between automation and robotics, which I see very timely. So I will not take more time of this distinguished panel. I'll give the floor to Ken.
Thank you so much, Sun. Greatly appreciate that. So thank you for the opportunity. And I am very excited about getting this group together. And I would like to start every presentation with a quick joke. So an infinite number of mathematicians walk into a bar. And the first one orders a beer. The second one orders half a beer. And the third one offers a quarter of a beer. And then the bartender stops him and he puts down 2 glasses, fills them both up, and says, "Come on, guys, you got to know your limits." Okay, that's the quick joke. And I'm going to give an overview of what we're going to talk about today. So I sometimes have to give. I want to note that we are here today, friends, Romans, and countrymen, to lend our ears to a discussion about automation and robotics, in particular, the synergies between the two of these. And I want to give credit for this acronym to our distinguished president, Seth Hutchinson, whom you'll hear from in a minute. And our primary audience for this session is the younger generation, which I have to admit is, I like to still think of myself as a member of, but I have to admit is probably, I'm not in that cohort anymore. But there's many new roboticists, many new automation experts, many new participants at this conference. And we want to talk about this topic of robotics and automation. And just to clarify terms, the word robot itself comes from a play that was presented in 1920 and is now 100 years old. So that word has been, I think most of us are familiar with what that is. Automation, however, is a more recent term. It was coined in 1948 at Ford Motor Company, and there's a lot of overlaps and relationships between them. So this is how we're thinking about it, that we have these 3 components. We have robotics, we have automation, and applications. And robotics, of course, is represented by the conferences, this one, ICRA, also IROS, and the transactions on robotics. And automation is represented in our society by the Conference on Automation, Science, and Engineering, CASE, and the transactions. And what we want to emphasize is the excitement and potential for research at the intersection of these 3 elements. So this is what we mean by synergies, namely when we start to think about robotics and automation coming together and interacting in constructive ways. One of them is in the commercial sector. So many of you are familiar with the many startups that have evolved over the last few years related to robotics and automation. And the idea is essentially that automation is required to take the innovations that sometimes come out of robotics and make them more efficient, more cost-effective, more practical, more reliable. So there's a very natural synergy here. When someone starts a company, a young roboticist starts a company, they very quickly find themselves doing automation. Now, the term automation is very widely used in context of home automation. And we're familiar with the advances that are happening here in home automation, which are extremely exciting and starting to evolve with the advent of of devices, such as the Alexa and Google Home. And I also want to recognize a very exciting new project that's emerging in Japan. The Toyota Woven City is a new project to build an entire city area that is designed for robotics and automation. Again, the idea of woven is that they're combining the elements of these two very important disciplines. We also see it in the success story of the company Kiva Systems, which has been used in warehouses now around the world. And more broadly, I see logistics as a sweet spot for robotics and automation. It's where advances in grasping and manipulation are starting to become widely applied to the growing problem of meeting the increased demand for e-commerce that has arisen during the past 18 months over the course of the COVID-19 crisis. Now, there's a number of well-known players from around the world who think about robotics and automation, sometimes controversially, but I want to note that if you think about Elon Musk, he's a huge fan of robotics, and Zuckerberg has a robotics division. And in a sense, though, they are both very, very deeply enmeshed in automation. There's also a number of books that address the issues around automation, and often critically. So it's important for us to develop a dialogue around these topics and think about what it means for the broader societies. Now, my favorite analogy is with these two gentlemen, that I think of the synergy between the two of them. And Steve Jobs, of course, was very charismatic and very good at design and communication, but he couldn't have succeeded without Steve Wozniak, who was, in some sense, the person who got things to work, actually built the circuit boards, built the systems, and fine-tuned them and made them efficient. So that's what I think of as a great synergy, a great partnership between automation and robotics. So I'm going to turn the floor over to our president, and I just want to acknowledge another Caesar, which is the sculptor based in Paris, who is well known for his sculptures on metal works and of various kinds. And I'll turn it over to our esteemed leader, Seth Hutchinson. Seth?
Thanks, Ken. You can advance one slide. So I'm going to give you just the old guy's view of robotics and automation and how we came to be where we were. If you joined this community in the last decade, even since the late 2004, 2005, that kind of time frame, you have always known us as two societies that somehow exist together, a bunch of robotics people and a bunch of automation people. And you may wonder, why did that happen? Why did this group of people decide to work together in the first place? And the answer is we started working together a long, long time ago. We started in 1984 as a society. And in those days, robotics and automation were really tightly coupled. If you were doing applications in robotics, there was a super high probability that the application was was automation. If you were working in automation, there was a very high probability that you were trying to get robots to do things repeatedly, very predictably in factories, to assemble things or build cars or that sort of thing. And that continued for quite a while. A lot of the robotics research done by people of my generation, whether you were doing dexterous manipulation or intelligent planning, no matter what, you were using a robot that weighed a couple of 1,000 pounds and was made to assemble cars in factories, right? So that was sort of the way robotics research was done, at least for manipulator arms back in those days. In the 1990s, things really started to change. A lot of technologies began to mature very quickly, and at the same time, computers got to be super fast, and all the mechanical stuff got better as well. And so robotics started to move out of the factory to a lot of other applications. And automation started considering a lot of problems that weren't necessarily robotics-centered problems. By the time we got to 2000, those two communities were publishing so much work, doing so many things, that we took what was the transactions on robotics and automation and split that into two separate journals, transactions on robotics and a transactions on automation, science, and engineering. We also spun up a conference devoted to automation called CASE that many of you know. It happens in hybrid mode in Lyon this August. Maybe it's your first chance to get to a conference. Lyon is not such a bad choice if it's going to be your first time back into the world. And those two communities did really well. The transactions on automation, science, and engineering really sort of started from scratch, while the transactions on robotics inherited all the prestige of TRA. But T-ASE has now established itself as a serious player in the world with a high impact factor, huge number of submissions, very low acceptance rate, all the things that you care about if you want to be a good journal. Unfortunately, one of the side effects of that was our two groups drifted apart. We drifted apart in what we think about, what we talk about, where we go to talk about those things, and maybe even some animosity rose up between those groups in subtle ways over the years. Now, in the, let's say the 2000 teens and so forth, it's not really beneficial to anyone to look at the world in that way, to pull the robotics and automation components apart. There are a lot of applications now where the robot and the automation really are required to work together for success to happen. And the example that I'll give you is self-driving cars. A self-driving car with a lot of sensors is a smart robot. And there's a real limit to what that car can do in the modern world alone. If you sensorize and instrument the streets, now you're doing automation. Large-scale automation with smart robots gives you the possibility for a sophisticated autonomous transportation infrastructure. There are a lot of applications like that. The smart home that Ken showed a minute ago is another, and there are plenty more. I'm going to stop there and just predict that we are on the verge of a period of, as you can see, blissful harmony, interdisciplinary innovation, golden age of robotics and automation. I'll hand it back now either to Ken or pass it on to Maria Fanti.
Okay, thank you. Hello to everybody.
Good morning, Maria.
Good morning. Yes, I would like to start with just a review of the history of automation. And the term automation is inspired by the word automatic, coming from automaton. The starting point of automation is the use of different control systems. And the simplest type of control system is obviously the closed loop, the control loop. Next slide. The mathematical basis of automation started in particular with the main advances in the 20th century. And different issues are very important. For instance, differential equation, frequency domain analysis, stochastic analysis, nonlinear control, digital control, and so on. But in 1947, Ford used for the first way the word automation, and for the first time, and established an automation department when in his industry he adopted the feedback controller. Next slide. And now the modern automation tools. Modern automation tools are artificial intelligence, machine learning, IoT solutions, digital manufacturing, 3D printer, big data, optimization, simulation, and digital twins. Today, automation describes a wide range of technologies that reduce human intervention on the basis of predetermined decision criteria. Next slide. Today, automation includes some enabled technologies that are in common with robotics. For instance, artificial intelligence, machine learning, IoT solution, human-machine interface, sensors, and camera system. These are some technologies that are in common with robotics. Robotics can be defined as an interdisciplinary branch of engineering and of science that includes mechanical engineering, electrical engineering, computer science, and sensors. Next slide. Now, it is evident the very large synergies between robotics and automation. And automation is intelligent transportation system, smart building, construction, vast management, video surveillance are applications that can be viewed as intelligent machines and intelligent systems that are not typically robots. So the synergy is very large, but also there is some fields where that we cannot include in robotics. And finally, next slide. Finally, I would like just to recall a field of automation in Horizon European program 2021-2027, where an example of automation is in mobility and in logistics areas, where cooperation, connected automation, mobility is expected to renew the travel and the move in not only in Europe, but also in the world. And in this context, the goal is to create through automation, a new mobility, a new approach in logistics. Thank you. Thank you.
Thank you so much, Maria, for that wonderful perspective from the history, which I think is so valuable, is to give the longer view. Speaking of history, we have next Pieter Liu, and I want to acknowledge that he was the transactions editor of TRA and was a co-founder of T-ASE. So he has a very rich perspective on automation. Pieter?
Thank you, Ken. Good morning, good evening, everyone. Thank you for the invitation. Next page, please. So my question to you is that as a person, as a researcher, do you want to have a good work or okay work or excellent work? Do you want to survive or do you want to thrive? So optimization is to achieve the best performance subject to relevant constraints. How about in your research? Do you face optimization on a daily basis? So major difficulties for practical problems is because the existence of discrete decision variables. Because of discrete decision variables, there's no gradient and there's no necessary condition for optimality. And because of practical size, the problem becomes very, very difficult to solve. So we have been working on to get near optimal solutions with quantifiable quality and fast for practical problems. Along the way, we developed a series of price-based decomposition and correlation methods. And recently, we are looking at formulation tightening. If successful, in extreme case, NP hard problems can be solved by LP methods. Next page, please. Let me just give you two examples. One is planning and scheduling of factories. So this to decide what activity, what risk to be performed on what resource and when. Very old problem, but a very important problem with new significance. And need to be solved very fast. Also, you think about your daily activities, you schedule it, how often is it interrupted? So for practical problems, it's really difficult to solve. So we developed, based on the previous slides, we developed a series of methods for factory scheduling, factory planning, extending to supply chain coordination and Industry 4.0. Next page, please. For smart buildings, looking at the buildings in the US, buildings are responsible for 70% of electricity consumption, 40% of energy use, and we spend 90% of the time indoors. But for temperature, for humidity, for CO2, for illuminance, they interact very complicated way. How do we integrate control and coordination of all these activities? That's a challenging issue, so we develop a series of methods on this, also for elevators and for HVACs and power plants. Next page, please. So looking at what Ken and Maria Pia said, because of Internet of Things, because of AI, machine learning, optimization, big data, and robotics, now, in addition to the routine labor work is replaced, non-routine tasks and decisions are gradually being replaced. It's an exciting era for automation and for robotics. So are we really addressing the challenges and grabbing opportunities? We have complex optimization issues resolved for you to optimize your research work. So my suggestion is to create ad hoc within RAS to investigate how to aggressively take advantage of the great opportunity and how to explore the synergy between automation and robotics. Thank you.
Thank you, Pieter. And in fact, I greatly appreciate your point. And in fact, that's exactly what Seth has done. And we have this new committee, the CSR, Committee to Explore Synergies Between Automation and Robotics. So that's what we'll be doing over the next few years. And I'm happy to say that Frank Park, the next president, is also very supportive of this. And we'll hear from Frank in a few minutes. Next, we have Pieter Abbeel, who will give us a mid-career perspective on this intersection between robotics and automation. Pieter.
Thank you, Ken, and hello, everyone. Thanks for joining us. So, as I was thinking about this automation and robotics relationship, for me, they really go hand in hand. The way I think of it is that automation provides goals. You want something automated. Maybe you want a building system automated, like Pieter was referring to, or maybe you want a car factory automated, and so forth. That's your goal. Then automation can bring to bear many tools, and as already alluded to, you can try to optimize which tools are used and how they can affect your whole process. This could be conveyors, guiding mechanisms, sorters, and so forth. In some sense, unlimited. No limit of 2 beers here, Ken. As many tools as you want. And robotics, of course, is the one that's closest to our heart for many of us because it's the most flexible tool. It's the thing, if the robot can just be smart enough, then it could maybe do almost everything, but actually in practice, often it's still helpful to have other tools at play. They can be cheaper and more effective than a general purpose robot. Next slide, Ken. One of the big reasons I'm particularly excited about automation, and there's also something Ken alluded to, is that I think it provides some of the biggest near-term opportunities for real-world robotics. So even if what you care about in your heart, what you care about the most is robots, and you'd like to see them maybe then actually do something in the real world, automation provides a lot of opportunities. To give you some examples, recycling. Of course, we should be recycling more. If some statistics here, 80% of the trash that goes into our landfills actually could be recycled. But of course, it has to be done. And how you're going to get it done. 30% of the produce that's being grown in our fields is actually not harvested. Again, because it has to be done, but there's nobody to do it. And the warehouses that we all rely upon to click on something online and get things delivered at our door, especially this last year and a half, the workers there have 7% injury rate on a yearly basis and 100% turnover. meaning that people, switch to a different job, 100% of the people effectively on a yearly basis. So there's a lot of need in all of these three sectors and many more sectors to bring automation, to bring us the kind of wealth that we want in the world for everyone. Somehow we need automation to help out. Next slide, Ken. So automation is what I think of as real world problem solving. It's holistic problem solving. It's okay if the robot is only part of the solution. It's okay to use other tools, but the full solution needs to be viable. And in fact, that can include, and will pretty much invariably these days include, thinking about the human as part of, I wouldn't call human a tool, but part of the solution is human and the robot, or human and other tools together, making sure things work. Because in automation, reliability tends to be key. And it's actually, I think, a big overlooked opportunity in research to really pursue high reliability. If you look at most papers, once somebody achieves, 80, 90% reliability on a task, they're pretty happy. And they might move on to a different research agenda, different problem. But for real world deployment, that's not enough. You need many nines of reliability. And that actually, I think, will require a different kind of thinking, different breakthroughs that we don't have yet. Thank you, Ken.
Thank you, Pieter. Really appreciate your perspectives here, and especially bringing up ideas like recycling, which is so timely today, and also your connections with the human-robot interactions and the potential for reliability research. So thank you for that talk and perspective. Next, we'll hear from another mid-career researcher, Kaneko Harada. Kaneko?
Thank you very much. And it's my great honor to be part of this wonderful panel. And I'd like to share my view by taking an example of lab automation and autonomous robots for lab tasks. And I'm going to highlight the differences. Lab automation is designed to provide a solution as a whole package and for mass production and small validation application, and works in known and controlled environment. Such an automation system can work in a real scenario. And in these days, a lab automation needs to become more adaptive for small production with a large variation. And in contrast, autonomous robots for lab tasks are designed by focusing on one difficult task, and therefore small production with large variation application, and work in environment with uncertainty. And unfortunately, most of such robots are demonstrated in a simulated scenario. And now such autonomous robots need to be implemented in a real life solution. So synergies between automation and robots are really necessary. Next, please. Thank you. And in fact, some months ago, we launched a new project called Moonshot, targeting science discovery. And we have discussed a lot about automation, robots, and humans. And we think that autonomous robots capable of research automation, which requires looping of hypothesis, planning, and testing and analysis, can co-evolve with humans to do science discovery. And we are discussing what robotic and automation technologies can realize this vision. Next, please. Thank you. And we think that we need to study two types of intelligence. One is for automation of research process or discovery process, and the other is for robot autonomy. And with such intelligence, robots can interact with humans. And we also have discussed that the robots and automation technologies are not to replace humans, but for humans to go beyond human limitations, to overcome environmental barriers, information barriers, and physical barriers, to have a complementary relationship with humans. And I think our community is the best place to discuss such a wonderful future. Thank you.
Thank you, Kaneko. I really appreciate this idea that automation can be used for discovery, and that it can be used in labs, and as we heard from Rob Wood this morning in his terrific opening plenary, it can be used for discovery in oceans and in hostile environments. And this is a very nice relationship to robotics and automation again, where automation has to continue the reliability at extreme conditions. Next, we'll hear from the current editor-in-chief of the Transactions on Automation Science and Engineering, Michael Wang. Michael?
Thank you, Ken. I will just share with you my view on the synergy between automation and robotics, and some of which have been shared by other members. So you probably have heard this saying that one robot is robotics, millions of robots are automation. So we all know every year there are thousands of robots being sold, a lot of them in China, and there are now more than a million of robots being deployed. So once you have robots together, employed in industries or somewhere else, they form a community or faculty. Therefore, they together do automation work. Next, please. So the synergy is that the robot is not by itself. It's part of a system, either production or other purposes. So there are a great deal of purposes for robots to perform in terms of automation. So I will briefly talk about three areas. One is automated production, where millions of robots are used. And the robots themselves have digital models, and they could be integrated for developing automation systems. And they're also to make robots become smarter, more intelligent, to be more interactive. And we have new techniques involving sensors and AI techniques. Next, please. So in a massive production system, robots are part of the system. They are optimized, and their performances are tuned such that an entire automation system produces the most product in a most economical way. And reversely, giving the performance limits as well as other requirements such as reliabilities, and the whole production system is optimized around whatever are in the system. So in terms of the whole product design to product delivery, robot is a very, very important integral part of it. And as also mentioned, there's a great deal of opportunities where the digital twin come into play. We have virtual representations of robots as well as other production machines, and they are integrated to be able to simulate the operational performance. And also with the real-time data, we are able to tune the parameters of these machines as well as robots to make them reliable, also much more productive. And to make robots, as we all have talked about, more intelligent, smart, and be able to communicate among themselves. And we now rely on IoT and quite a lot of big data sciences, as well as AI technologies. Therefore, with not just single robot, but millions of robots, we actually have a much larger ecosystems, what we call automation. And the synergy is obviously very obvious. Therefore, our transactions on automation science and engineering covers from the product design to the techniques of automation, including robot development, robot technologies as well, with a holistic perspective and a holistic approach. That's my personal perspective. Thank you.
Excellent. Thank you, Michael. And I want to also give credit for that analogy to Raja Shatila, our past president of Robotics and Automation Society, who made this point about one robot being robotics. And when you scale robots to tens or hundreds or thousands or millions, that's when you get into automation. So this issue of the scaling transition, that leads us into automation. Next, we'll hear from Chinwe Ekenna to give us another junior perspective on this intersection. Chinwe?
Hi. I'm also going to be giving a little bit about what I think about and what my view is about this synergy between automation and robotics. And I'm going to take it from a little bit slightly different perspective, where I'm looking into extending beyond to where there's actually a dire need. So talking about this company Zipline, what they do basically is they provide healthcare services by sending this drone to very remote areas. So they've been able to provide some kind of synergistic interaction between robotics and automation, which is why I have this image here. This gives you a way to actually appreciate what's currently being done and where it's actually a very dire need. So they've been able, they send in health products, they send in very important things to remote areas where you basically cannot send in cars or send in people because it's very, very risky and very difficult. So the next slide, please. So even with that, looking at one of this preliminary success that we've had, there is actually a lot of room for improvement. There's a lot of room for where we could actually have this kind of interaction become very useful and really make a change in people's lives. So another thing could be even in the area of shipping. Shipping in some parts of the world, the bottleneck in there is really a lot of work has to be done. So bringing in, I'm just bringing up some potential and areas where we could actually see this synergistic process and prospects actually being very useful. Agriculture is another one. There is like a lot of research, robotics and agriculture, thinking about reapers, or thinking about automation within the farm, within the farming environment. Now, looking at agriculture, even in these very remote areas, and how we can actually bring in robotics and automation is something, if you think about in the near future, very worthwhile. Healthcare as well, as we all know. So this synergy basically has the potential to bring a myriad of positive changes in different sectors. Finance is also included. And it will actually bridge the gap between physical infrastructure inadequacies in certain parts of the world, consumer demands, and then it can actually free up some skilled labor, and in the sense of that, also increase labor productivity. So that's basically my view. My view is really looking beyond towards where we could actually see a dire need and where the success of this synergy would actually come into play. Thank you.
Oh, thank you so much, Chinwe. That is I think that's so important for us to be thinking about the global perspectives on the issues that we're talking about. And I also want to say again that I appreciate the views of that we have views from junior representatives and senior representatives, as we'll hear in a minute. And I also want to say we have 3 more speakers, and then we're going to open it up for some questions. And I welcome you to enter questions. We want to engage in a dialogue with everyone, and we have an opportunity today because we have thousands of people online. So next is Kevin Lynch, who was currently the editor-in-chief of the Transactions on Robotics. Kevin.
Thanks, Ken, and thanks for organizing today. A benefit of going late in the schedule is that I get to just draw off of what people said before, but particularly Pieter, I think, raised this distinction well, that much of robotics is about producing proofs of concept and videos and 90% performance. And of course, the people, right? Robotics research is producing the people that's driving both robotics and automation. Whereas when you go to automation, you're talking about scaling, optimizing, making reliable, robustifying, and eventually producing profits. And naturally, automation is going to be more closely tied to applications than some of the robotics work that we do, because if you want to think about it this way, you can think of robotics as sort of the core of where our society is, because we're touching on robots somehow within RAS. But as we expand out into applications, we're passing through the automation stage. So another way to think about it, we have the Venn diagram from before, but you also might think that automation is sort of allowing us to do the transition from the proofs of concept out to real world solutions. And so Ken mentioned that we're really focusing on younger audience today who want to know where robotics and automation fit within RAS. And a lot of you are writing your papers right now, but many of you, and this is a little bit different than 20 years ago when I was, well, okay, more than that, when I was coming out, a lot of you are going to go to startups or starting your own startup or going to small companies. And that process is really about taking the proofs of concept, the things that you could do, and now making it reliable so that it's actually something that somebody wants. And so it's not a question of which kind of work is more fundamental. They're different and they're both critical to have a real world impact. Can you go to the next slide, Ken? I just wanted to talk briefly about my own perspective. So I've been very fortunate to serve the Society in many editorial roles. As Ken mentioned, I'm currently the editor-in-chief of the Transactions Robotics, but I also was able to serve as editor-in-chief of the conference of ICRA, as well as senior editor for T-ASE and for RAL. So I've had a chance to see papers being submitted to a variety of different communities, and it's given me some appreciation for how all of these pieces work together. One thing I wanted to mention, I'll talk about TRO for a second, is that we have a policy that's been in place now for the last couple of years that if you write a new paper and you submit it to Transactions on Robotics, and it's accepted Transactions Robotics, then you'll be offered the opportunity to present that paper at an upcoming ICRA or IRAS. So this is a way, if you want to make the first version of the paper your 12-page version, not a conference version, then a longer journal version, submit it here. If it's accepted, then you'll also have the chance to present it at a conference without any alteration. You don't have to make two different versions of it. And I mention this because I think soon, maybe all of our journals will go to a model like this. So this is something to keep an eye out for. There's a proposal now for, well, REM, so our Robotics and Automation magazine is already doing this. The Robotics and Automation Letters has a different model, but it may soon be moving to a model similar to ours, and T-ASE also. So there's a strong tie-in between our conferences and journals, and that's an even more motivation to be submitting to RAS journals. So I'll stop there, Ken. Thanks.
Thank you, Kevin. And thank you for all your service to the society in a variety of levels and over the years. I also want to note that our current, the upcoming T-ASE editor-in-chief is going to be Yu Sun, who is also serving as the general chair of this conference, the program chair. And he is doing an incredible job. And I want to thank him also for his wonderful service and for inviting this panel. Next, we're going to hear from Animesh Garg, who is a new junior researcher at the University of Toronto, to give a perspective on this intersection of robotics and automation. Animesh.
Thank you, Ken, for moderating this. If you can go to the next slide. Yes. So when I started doing research in robotics about 10 years ago, there was a clear distinction between robotics and automation. Robotics was about building systems to operate in open world, often with a focus on general purpose hardware and software. And robot in a home was frequently quoted as the North Star problem of the field. Automation, on the other hand, was a special purpose systems aiming to solve problems in structured environments, and robots assembling cars and cages was the quintessential example of such a system. Next. However, over the last decade, progress in autonomy, improved hardware and sensing, and algorithms in AI have blurred these boundaries. In fact, I would argue the notion of AI itself is more about ambient intelligence to support the many spheres of our activity, whether it is at home or at work. And these spaces will operate, not only will have robots as we know it, but probably also devices that are smart in the sense that there are multimodal sensing, perhaps other modes of control. Your curtains are automated, or as Pieter pointed out, automated material sorting in a factory. And in the same way robots are stepping out of the lab, we can also see automation is increasingly stepping outside the cage into applications with fewer structured constraints. Next. So a classic problem that we can use as an example is factory. An automated factory needs operations that include material handling, assembly, finishing, which in turn may require autonomy in manipulation and mobility. And often roboticists may scope the problem to either just navigation or manipulation operations at a station, maybe grasping objects in a bin. On the contrary, automation may need to study the holistic problem of material handling in a factory, of which bin picking is definitely a very vital part, but it may also need to look at the context-aware decisions that need to be made in view of information coming in from many pieces of equipment in the factory. And now the things that we're building in terms of these digital twins allow us to solve these problems jointly, both automation and robotics. Next slide. So as we build toward a framework of this ambient intelligence and autonomy, a myth that has plagued the community, I would argue, is automation is a last mile problem. It's just engineering. Next. I would argue that actually both robotics and automation each have technical problems that are equal parts science and engineering. Robotics has the technical problems such as how to build better decision-making systems, improve robot control and design, and also building a higher level of cognition and reasoning. On the contrary, automation have questions that are, how do we build context-aware awareness from network sensing and control? How do we build algorithmic methods for quality assurance, transfer and few-shot learning? Importantly, as Pieter pointed out, uncertainty quantification and even long-tail performance guarantees to get the right number of nines we need. And as roboticists, I would argue the path to achieving impact in our work is very likely going to be hand in glove with progress in automation. Next slide. And to finish up on a lighter note, many of us in the robotics community have been solely focusing on building the Iron Man only as a suit. Can you go next? Okay. But it wouldn't be half as impressive without the context-aware automated assistant that is what we call Jarvis. So I would argue that embodied AI in physical environments needs both robotics and automation, not one or the other. Thank you.
Excellent. Okay, thank you so much, Animesh. I really appreciate that analogy, and it's even better than my my Steve Jobs and Steve Wozniak one, because you're absolutely right that Iron Man and in the series is totally inspiring, and there's robotics and there's automation working together. And as you said, there's this transition out of the cage from traditional automation that's happening around the world, and so your perspective is right on target. Okay, our last speaker is going to be Frank Park, who has been a past editor-in-chief of the Transactions on Robotics and will be our next president of the Robotics and Automation Society. Frank?
All right, thank you, Ken. I'll be brief. So I would regard this event and others like it to be a failure if we just ended up congratulating ourselves and each other for our observations and insights about robotics and automation. And then we just went back to what we were doing before, and this event just becomes an archive video somewhere. So we need concrete plans that put into action many of the great ideas that our panelists proposed. And not only more discussions like this, but long-term sustainable activities, I think, that engage both the robotics and automation communities, especially our younger members. So just some obvious things that I can think of. I hope that people who primarily consider themselves roboticists and only attend ICRA and IRAS and publish in T-ASE and RAL consider attending CASE and submitting your works to T-ASE. I think it's very important. I'd like to see the editorial boards of our robotics journals, TRO, but especially RAL, have better representation of members who consider themselves more mainstream automation. Hopefully we'll see more articles and special issues addressing topics that help break down these barriers that exist. I'd like to ask the automation community also to be more inclusive and receptive to more traditional mainstream robotics. Many of the papers on grasping and manipulation bank picking, for example, that we see in TR and RAL, for example, I think they could just as easily be at home in TASE and CASE. I'd like to see more events like startup fairs and boot camps organized by our Industrial Activities Board, for example, that bring together the two communities and break down these barriers. Pieter and other folks who've launched startups should, obviously continue to preach the message that, in industry, nobody cares whether you call yourself robotics or automation. Does what you have work? And at a practical level, there really is no difference. So these are some of the concrete actions that I think we can take, and really the mission of this committee. I think the more challenging and subtle aspect, and one that I hope will occur naturally once we take all these steps, is to change perceptions and stereotypes about robotics and automation. And I will confess that for many years I also thought automation as mostly operations research, and I have to thank Ken for changing that perception for myself and also many others. Clearly the job is not done, and that's why we've called upon Ken yet again. And with that, I'm happy to turn it over back to Ken to hear more suggestions and ideas from what the audience has to say. Thanks.
Thank you so much, Frank. And I appreciate what you're saying from your perspective about really concrete plans. I completely agree with you. And I think this is actually what we need to start thinking about next. This is not just an overview. This is really the beginning of a process that we want to continue, which is to really bring these two hemispheres together and change perceptions and the stereotypes. And I would say one thing is that CASE Conference on Automation, Science, and Engineering is actually a really interesting opportunity for that, because it's a small and growing conference, just announced its accepted papers today, and is going to be held in Lyon, as Seth mentioned. And this is an opportunity to start to bring these elements together. So please consider that for future papers. We have a few minutes left, and I want to open up for questions. I also created a doc, a Google Doc, that's open for editing from anyone. This is the URL is at the top, and please pose questions, comments, suggestions, links, and volunteer to get involved on that document. So with that, I'm going to turn over for some questions, and I'll kick it off by just asking Pieter again, as Frank just mentioned, you're an entrepreneur here. You have started Covariant, which is a successful company, and you've got a real perspective as everyone admires you as a roboticist. But can you say just a little more about how automation plays in terms of your own entrepreneurial experience?
Sure. Yeah, I think what's so interesting about going into the real world is you talk with people, you ask what they want, right? I mean, that's the key to building something they'll actually use. And so for us, I mean, it was always very clear. Well, first, it wasn't clear where we're going to go, but after asking around, it was very clear that there was such a dire need, specifically in warehousing. So, but when you think about what's a dire need for automation there, ultimately, it's clear that you need to meet a certain level of performance. If you don't, it's just a nuisance. It's just a research project, and you might end up in the innovation center of the company that's just checking out your automation solution, which in our case is largely robotic, but there's many components to it. And to get beyond the automation center or the innovation center fun appearance there into real production really requires this kind of levels of autonomy of the whole system, robot and everything around it, which I think is super interesting, that it brings so many other things to play. Even though at the core for us, definitely the robot does most of the work, there's many other factors involved.
Thanks, Pieter. Great to hear that from your perspective. And I want to also just ask Kaneko and Michael to just say quickly a few words about the perspective on the word automation in Asia, because I think there's a difference. And in fact, there are many departments of automation across China. And I'm just wondering if maybe Michael, you can respond to how that term is being used.
Yeah, so automation has been regarded as a fairly advanced level of production, especially because of the traditionally lack of technology in the industry in China. And once Asia and China started to move into industrialization, people are very much fascinated about automated production and not much into the moving arm, legs, machines, robots. So today, obviously, it carries heavy weight because of the economy, because of the scale of manufacturing and the competitiveness in the global competition to bring the costs down. So there is a great deal of prestige in automation and a great deal of expectations for the economic.
Thank you. Thank you, Michael. And let me ask, there's a question that came up here from Felix von Drigalski, who is asking for some perspective on, he said, automation or robotics technologies that we had high hopes for. I want to turn that around, actually, that I would say, let's look at the other way around. What are the technologies in automation and robotics at that intersection that that have surprised us by how influential they've become? I want to open that up to the whole panel. Anyone could jump in. It's a little too early in the morning for some of you. All right, I do want to say that I want to, just as I'm watching the clock, and I want to respect our time. This is something we can continue to discuss on the Google Doc. I want to welcome you to do that. I want to apologize for the delays in transitions on the slides. That was just a system error, system problem, but we had to deal with it. But I also want to thank again this incredible group who's put in a huge amount of volunteer time on exchanges, on sharing ideas together, and preparing for this panel. And again, want to thank you, Sun, and all the organizers for ICRA for giving us the opportunity. So I'll turn it back to you.
Thank you, Ken. Thank you, everybody. Thank you very much for forming this panel. I think our panel deserves a whole day instead of an hour. There are many, many issues we haven't touched upon. We have 2 more minutes. Maybe I can take the liberty that we wanted to define. We try to define robotics automation separately, but it's very hard because a lot of times they're not separable. And 2 good examples. There was one question in the QA box asking about healthcare robotics, or not healthcare robotics, healthcare issues. So that's a good example. We think about surgical, maybe it's more robotics. We think of healthcare scheduling, the surgical procedure scheduling, maybe it's more automation. If I have to choose a side, similarly for warehouse handling, we see a lot of robots, mobile robots, but to fulfill an order, that takes a lot of back the CM type of automation issues. So I thank Ken again and everybody for forming this panel. But in future, I propose we do a full day workshop to go in depth to touch upon a lot of these issues that we started today. But last minute to inform all our panelists, so far we have 6,700 people on the live broadcast platform, plus 328 in Zoom. So we have 7,000 people. So I think our mission is achieved. At least this discussion has been heard. And I hope all our researchers, especially young colleagues, to continue to communicate with us, not to separate robotics automation, but to synergize them and strengthen them. And I will bug Ken again to work with all of us to coordinate a longer event to go in depth. So Ken, maybe a couple more words from you.
Thank you, Sun. I would take that with great pleasure. And congratulations on that amazing turnout. I want to end by noting what Seth began with, which was that we're entering a new era. And we're coming out of a period that's analogous to 1918. And this is a new roaring 20s I see ahead. And I think the attitudes that we've heard today, the insights and perspectives are emblematic of what we're going to see in the next decade. Very excited about it. Thank you all. And on to the rest of the conference.
Thank you, everybody. Thank you very much for the fantastic panel.